Welcome to 6.1, Rational Expressions and Functions. We're going to learn how to find the domain of a rational function, simplify rational expressions, and use rational expressions to model and solve real-life problems. So first off, the definition of a rational expression. So if we let u and v be polynomials and we make them a fraction, this is a type of rational expression. Now remember, u and v can be any polygon, so it can have 3 degrees, 4 degree, or 2 degree, even 1 degree. The domain of this rational expression is when the denominator does not equal 0. So when does v cannot equal 0. So we need to figure out what values will make our denominator 0, and then we'll have all real numbers except when v doesn't equal 0. Now a rational function, same type of thing, except u and v are polynomial functions. So if we put u and v as a fraction and then make it a function of f, this is a rational function. Just like with expressions, the domain of a rational function is all real numbers for which the denominator is not equal to 0. So let's start off with finding the domain of a rational function. Let's start with function f. So it says 4 over x minus 2. Well, remember, we cannot have 0 in our denominator, so we need to figure out when will this expression x minus 2 be equal to 0. Well, if I solve this equation, I'd add 2 to both sides, and I get x equals 2. So when x equals 2, our denominator will be 0. We don't want that. So the domain of function f is all real numbers except x cannot equal 2. Now for g, again, we don't want our denominator equal to 0, so we need to figure out what values of x will make x squared minus 16 equal 0. Now I know how to solve this from chapter 5. This is a difference of 2 squares, so I'm going to factor this into x plus 4 and x minus 4. Now remember, also from chapter 5, we're going to set up our two equations when x plus 4 equals 0 and when x minus 4 equals 0. This will lead to x equals negative 4, and this one will lead to x equals positive 4. So the value of 4 and negative 4 will make our denominator equal to 0. So for our domain, we can have any numbers, we can have all reals, except we can't have x equal positive 4 or negative 4. Now simplifying rational expressions. So keep in mind that we need to list our domain restrictions. So that's just what we did over here. Our restriction on the function f was 2. X couldn't be 2. And on the function g, x couldn't be positive or negative 4. That's what it means by listing any domain restrictions. So when we go to simplify, notice up here that if u, w, and v are either real numbers, variables, or algebraic expressions, we can cancel them out when it matches on the top and the bottom. So for instance, let's look at this first example. It says to simplify. Well, I need to factor this. So I'm going to factor the top of the equation, and I notice that I can pull out a 2x from both. So once I factor out a 2x, my first term is left with an x squared, and my second term is left with a 3. Now in the bottom, there's nothing that I can pull out, but I can separate the 6x squared. I look and I notice that in the top I have a 2x. If I can have a 2x in the bottom, it will cancel. So I'm going to factor out a 2x And when I do that, I'm left with 3x. This is good because I can cancel out my 2's because they match, my x's because they match, but nothing else will cancel. I can't cancel this 3 and this 3 because they're not identical. So in my numerator, I have x squared minus 3, and in the denominator, I have 3x. Notice I cannot cancel my x's. Now for the bottom one, we also have to factor our numerator. So this is a trinomial, so we're going to factor it into 2 sets of parentheses. I need to think what 2 numbers multiply to negative 15 and add up to positive 2. I know x goes in the first position, and I know that a negative 3 and a positive 5 will multiply to negative 15 and add up to 2. In the denominator, I can factor out a 3. When I factor out a 3, I'm left with x minus 3. This is good news because I notice I see an x minus 3 and an x minus 3, the top and the bottom. So I'm going to cancel those out. My numerator, I'm left with x plus 5. Denominator, I'm left with 3. Now you may be wondering, I said that we had to list any domain restrictions, so we're going to go ahead and do that off to the side. We need to list what x cannot equal. Well, again, we don't want our denominator to be 0. So we could set 3x equal to 0 and solve for x. And I get 0. So we can't have x equaling 0 in our denominator. Down here, I don't need to worry about x. Our denominator is 3. But notice at our beginning, our domain would have a restriction. So if 3x minus 9 equals 0 and I solve for my variable x, I'd get x equals 3. So our one domain restriction is that x could not equal 3. So be sure that you check the original and whatever you factored. The original and whatever you factored the denominator to be. I have 2 more examples here. Let's go ahead and factor so that we can simplify this expression. I can take out the top and x, and I'm left with x squared minus 16. In the denominator, I can also factor what 2 numbers multiply to negative 8 and add up to negative 2. X goes in the first position, and I have negative 4 and positive 2. Notice up top I have the difference of 2 squares, an x squared and a 16. So I'm going to factor that into x plus 4 and x minus 4. In the denominator, I have an x minus 4 and an x plus 2. Let's cancel out what they have in common. In the bottom, there's an x minus 4, in the top, an x minus 4. Nothing else is in common, so I repeat what I have left in the numerator and what I have left in the denominator. That's as far as I can go. Now, restrictions on the domain. We can't have our denominator equals 0, so I need to find out when x plus 2 equals 0, what x equals negative 2. So x cannot equal negative 2. Also, look at the original. We have an x minus 4 in the denominator, so I need to check when x minus 4 equals 0, x equals positive 4. So x cannot equal negative 2, and it cannot equal 4. Notice how I checked the original and the factored. All right, down below, I'm going to switch to green. I need to factor the numerator and the denominator. Now keep in mind the numerator is a little tricky. We're going to have to factor by grouping. So I need to decide 2 times 4 would give me 8. I need multiples of 8 that add up to -9. So let's list multiples of 8. Well, I have 1 and 8, and I notice that if I add those, I'd get 9. Well, I need a -9. So what about -1 and -8? When I add those, I do get -9. So this is the pair that I want. I'm going to use this pair to rewrite -9. So I have 2x squared in the first position, and instead of writing -9x, I'm going to write -1x minus 8x. Remember, those came from the factors of 8 that add up to -9. And then obviously I have my plus 4 on the end. Now down below, it's not quite in standard form, so I need to write this with the x squared term first. Now remember to keep the sign in front of the x squared, so it's a -x squared, a positive x, and a positive 12. Okay, now it's in standard form. I'm going to go back and focus on factoring the top equation. Remember from chapter 5 that we factored this by grouping. So if I were to group together the first 2 terms and the last 2 terms, and in the bottom, I want my first term, my x squared term, to be positive. So I'm going to factor out a negative. That's going to change the sign of every term. So my x term became negative and my 12 became negative. Now back to the top, let's factor out what each set of parentheses has in common. So I'm taking out an x from the first set, and I'd be left with 2x minus 1. Now in the second set, I'm going to factor out a -4, and I'd be left with a 2x minus 1. In the bottom, I can factor my set of parentheses into 2 binomials, or 2 sets of parentheses. So what 2 numbers multiply to -12 and add up to -1? That would be a -4 and a +3. Not quite done. In the numerator, I notice that a 2x minus 1 is in both groupings, so I'm going to pull out a 2x minus 1, and what I'd be left with is an x minus 4. This is looking promising because I have an x minus 4 in the denominator. So I'm going to cancel out a denominator and a numerator, whatever they have in common. Nothing else cancels, so I have a negative, remember, from the bottom, 2x minus 1 in the numerator, and x plus 3 in the denominator. This is as far as I can go. I've simplified it, but I need to list my restrictions. If I set this denominator equal to 0, I'd find out that x equals -3. So the one restriction on our domain is x cannot equal -3. And I want to go back and check my original factored denominator. So up here was my factored denominator. Another term I see is x minus 4. So when x minus 4 equals 0, x equals 4. That's another restriction we have on our domain. Rational expressions involving 2 variables. Now let's read this study tip. Keep in mind in the next section and the 4 following that we're just rewriting expressions in simpler forms. We're not solving equations. Okay, equal signs are used in the steps of simplification process only to indicate that the new form of the expression is equivalent. So what that means is, on this last slide, when I kept writing equals, 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 that just means these are three equivalent forms. It's not an equation. They're equivalent expressions. So let's try and simplify with two variables. Let's work on the top one. We're going to do the same steps. We're going to factor. Now in the numerator, what do they have in common? Well, I see an x in the first one, but not in the second one, and a y in the first and two y's in the second. So I'm going to factor out a y. Factoring out a y would leave me with 3x plus y. In the denominator, I have a 2y. So let's look at what they have in common. I see a y here and a y here. I'm going to cancel those out. That leaves me with 3x plus y over 2. There's nothing more to simplify. I can't simplify my 3 and my 2. Let's list our domain restrictions. The original factored denominator was 2y. So when 2y equals 0, y equals 0. So one restriction we have on our domain is that, sorry, not x, but y cannot equal 0. On the bottom one, I'm going to factor out what they have in common in the numerator. So I see a 4 in this first grouping, but not in the second. I see an x squared, but I don't see an x in the second. And a y is in both. So I'm going to factor out a y. And I'd be left with 4x squared minus y squared. In the denominator, I notice that they have at least one x and one y in common. So I'm going to factor out an xy. When I do that, I'm left with 2x minus y. Notice I'm left with one y because it was y squared, and I'm only taking away one of them. Now, in the numerator, it's not fully factored yet because I notice in my parentheses that this is the difference of two squares. So I have a y out in front, and the difference of two squares, remember, gets factored into two sets of parentheses. One's positive and one's negative. The first term in the parentheses is the first thing being squared, while the first item being squared is 2x. The second item being squared is a y. And the denominator can't be simplified anymore. And I notice that in the numerator is a 2x minus y and a 2x minus y in the denominator. I also notice that there's a y here and a y here. So simplify this. Numerator, 2x plus y. Denominator is just an x. The reason I can't cancel out these x's is because it's not over here in this second term. Remember, terms are separated by plus signs or minus signs. So this is as far as I can simplify. Let's see if we have any domain restrictions. We're going to look at this first factored denominator. Remember, we can't have x could be 0, y could be 0, or 2x minus y could be 0. So x is already solved. We know x can't be 0. That's a domain restriction. Y is already solved, so y can't be 0. But now we have this equation here. So if we're going to solve for our variable, let's say y, I'm going to add y over, and I get 2x equals y. This is as far as we can go. I'm never going to be able to solve any further than this. So another restriction we have is y cannot equal 2x. So I've solved for one variable y, and it can't equal the left side, which is 2x. Those are my 3 domain restrictions. All right, this is 2 variables continued, so just get some extra practice factoring. In the numerator, I notice I can't take anything out of it, but I do have the difference of 2 squares. So I'm going to factor this into 2 sets of parentheses, one's plus, one's minus. First thing being squared is y. The second thing being squared is 8x. In the denominator, I have a 5 already factored out, and it looks like in my parentheses I can take out a 3. So when I factor out a 3, I'm left with y plus 8x. Notice what we have in common, a y plus 8x and a y plus 8x. I'm going to simplify. Numerator is y minus 8x. Denominator, I have a 5 times a 3. Those are just numbers that I can multiply to give me 15. Now, domain restrictions. I'm going to check the first factored denominator, and I see that I have 5 and 3. I don't need to worry about those. I need to worry about my variable expressions. So that'd be y plus 8x equals 0. I need to figure out when he is 0. So I'm going to solve for y by subtracting 8x. And I get y equals negative 8x. So there's my first restriction. Y cannot be negative 8x. Down below, I notice that I can factor something out. I can take out a 4uv. That's a lot that I can take out because each term, this one and this one, both have a 4. They both have at least one u and at least one v. So when I take out a 4uv, I'm left with 1u here minus 3 and 1v. In the denominator, I have 18 uv. Let's see what we have in common. A v and a v, a u and a u, and I have 4 over 18, which I can simplify. They both can be divided by 2. 4 divided by 2 would leave me with a 2. 18 divided by 2 would leave me with a 9. So when I rewrite this, I have 2u minus 3v over 9. And that's as simplified as I could get. Let's check our domain restrictions. So again, let's check our factor denominator. When 18uv equals 0, if I divide by 18, uv equals 0. So either u equals 0 or v equals 0. That's our domain restriction. We cannot have v equals 0 or u equals 0 because they will turn our denominator to 0, which is no good. The last slide is finding a ratio. So we want to find the ratio of the area of the shaded portion of the triangle to the total area. Now, if you remember, ratio just means a fraction. So we're writing a fraction with the shaded area over the total area. So let's first find the area of the shaded triangle. If you remember, area of a triangle is 1/2 base times height. So let's look at our shaded triangle. We have 1/2 the base, which is 4x, times the height of this triangle, which is x plus 2. Now I'm going to simplify. I'm going to distribute my 4x. So I have 4x squared plus 8x. Now I'm going to distribute my 1/2, and I'll get 2x squared plus 4x. That's the area of the shaded triangle. Now let's find the area of the total triangle. Again, it's 1/2 the base Well, the base of this is cut in two pieces. It's cut into 4x and a 4x. So I'm going to add the 4x's so I get the length of that entire base times the height, which is x plus 4. I'm going to combine like terms here. I have a 4x and a 4x, so this would simplify to 8x. And just like up above, I'm going to distribute. 8x times x would be 8x squared. 8x times 4 would be 32x. Once more, distribute your 1/2, and you get 4x squared plus 16x. This is the area of the total triangle. So like we said, we wanted to make a fraction, a ratio, with the shaded area on top and the total area on bottom. So the shaded area was 2x squared plus 4x over 4x squared plus 16x. Now we just talked about how to simplify something like this. So we're simplifying this rational expression. In the numerator, I can take out a 2x, and I'd be left with x plus 2. The denominator, I can take out a 4x, and I'd be left with x plus 4. Let's cancel out what they have in common. I see an x here and an x here. I can't cancel an x plus 2 with an x plus 4, but I can simplify my 2 over 4. This will simplify to 1/2. So I'm left with an x plus 2 in the top and a 2 times x plus 4 in the denominator. This is the ratio of the shaded portion to the total area of the triangle. And that concludes 6.1 notes.